Hi there, this is Ken Oestreich. I'm Vice President of Product Marketing here at Egenera, and I'd like to take a couple of minutes here to talk about infrastructure orchestration and what we mean by it. First, what exactly is it? Well, it's something that simplifies, I'm going to annotate here a little bit, the configuration of servers, software, I/O, storage, HA and DR policies, and no rewiring. So this is very, very different than what software virtualization is. Let me illustrate how. What we're talking about is configuring servers, how they're set up, what the network interfaces are, storage interfaces, your network and storage switches, essentially how they're wired and networked together, and replacing these manual configuration steps with a automated software one, where essentially with a mouse you can configure an entire server profile for either immediate or future instantiation, and give that profile properties of high availability and or disaster recovery. So where do we all go wrong? Why are we talking about infrastructure orchestration? Well, motherboards, typical computer motherboards, they're stateful, they're individually addressed, they have static network I/O and storage, which means when you need to fail over, or when you need to migrate, or when you need to change a CPU, you need to change all of these properties about the server. And what we want to get around is the statefulness. We want to go to CPUs that are stateless and therefore repurposable. Well, how do we get there? It helps to know a little bit about how we got where we are. So far, along the evolution of software, you'll notice that we started with very tightly bound software to CPU. There was one OS per CPU. There was no software portability. And we had hardware that was very tightly bound to I/O and storage. As I said, the network interface cards here, the host bus adapters for storage, their addresses were very, very tightly bound to the CPU. So enter virtualization, enter the hypervisor. And what we have here now is a hypervisor draws a line that abstracts the software from the compute hardware. So now we're allowed to have many OSs per CPU, OS portability, and you can do services like HA. So for example, you can essentially slide in applications and OSs on top of that hypervisor. The issue we still have is the hardware itself down below is still tightly bound to its I/O and its storage. I/O is still locked to the CPU. That CPU in here is still stateful because all the addressing and whatnot that goes on below it. So what are we going to propose to do? What is this infrastructure orchestration business? What we're doing here on the diagram is we're going to try and abstract away all these stateful properties. So we're going to take those NICs and those HBAs, and we're going to essentially abstract them away from the physical processing right in here. And what you're essentially doing is now we have, obviously with a hypervisor, abstracted away the software. With infrastructure orchestration, we're abstracting away the I/O. We're leaving ourselves with a stateless physical processing layer here. So here we go, a little bit of diagrams, of what we're doing. Stateless infrastructure, I/O that's logically removed from the CPU, and that way we can assign essentially any I/O or any I/O for configuration to any CPU on the fly, and we'll talk about why that's so valuable for HA and for DR. So what can we do here? Infrastructure orchestration permits replacing or scaling that the compute layer without altering the software. Why? Because we're able to control how this software is booted onto the CPU and how this I/O is configured to the CPU. So we can create or modify I/O storage logically, not physically. So what do we mean? It means that essentially we can slide in and slide out CPUs, right? Capacities, or for when new capacities, or for when a CPU fails. And similarly, we can change essentially I/O on the fly, and I/O and addressing on the fly. So where does that bring us? Well, it brings us to an interesting set of properties. A logically managed compute I/O and network system. We have stateless CPU, as I've said before, and we can unify management of physical and virtual. So we have a typical virtual server stack on the left, a typical physical server stack on the right, and when we add in the capability of infrastructure orchestration, we can pool CPUs. We can essentially pool how network and storage connectivity is assigned, and we can then create, for example, very highly available software stacks and hardware stacks, regardless of whether the payload is virtual or whether the payload here is physical. And we'll illustrate that in the next slide or so. So let's take another picture of how you might want to view this, where we have a couple of virtual stacks here, physical stack over here, and conceptually what we're going to do in infrastructure orchestration is we are abstracting how all of this infrastructure is connected to the CPU. We end up here with essentially stateless compute because we've abstracted away this infrastructure for networking. We replace it with a unified fabric, which is logically configurable. Sorry about my diagrams here. Logically configurable or reconfigurable. We'll add in, obviously, connections to the real world so that we can connect to storage, so that we can connect to local switching. And what this fabric allows us to do is create either point-to-point connections or not secure connections, or essentially reconfigure how the networks are connected in real time without actually messing with the addressing that's on these CPUs. The CPUs are still essentially stateless. Now, what does this get us? Well, if we have a failure, take a failure for a virtual host. What we can do is take the configuration of this failed CPU and reproduce it on a new CPU, then reattach that CPU to the storage and reboot the host and the recovered guests on that new CPU that will look exactly like the failed CPU. Similarly, in a physical world, if that CPU fails, we're going to be able to essentially clone the CPU that was failed onto a new CPU with all the addressing, all the storage, and all the networking connectivity, and then reboot that physical app onto a CPU. Right? So let's extrapolate now into a larger data center, where a long time ago, physical availability had to be one-to-one, where you had clustering or where you had mirroring, where the servers absolutely had to match, and this was very, very poor capital use, capital efficiency. Obviously, with the advent of hypervisors, you can begin to fail over onto an available host if you have one, but that requires dedicated warm hosts, if you will, to be sitting by as failover hosts. But it doesn't help your physical applications at all. But enter infrastructure orchestration, or this concept of network fabric, where you can essentially have a bare metal CPU back up and fail over either physical servers or virtual servers. It doesn't matter. This is stateless and available when you need it, how you need it. What does this look like in real life? I'm just going to populate this slide. GUI for an Egenera product is where you can configure in software what servers you want for your applications, whether they're virtual or physical, what you want the storage connectivity, the I/O connectivity to be for your NICs or your Ethernet switches for that server or set of servers, how you want your storage to be configured, local disks, HBAs, SAN switches, which switches and storage connectivity you want for which servers, and obviously what OSs you want booted onto those machines, what consoles you want attached. And then the kicker is, once you've defined that server, how do you want to define the failover and or disaster recovery properties for that server? Do you want that server to fail over at all, and if so, onto a specific box or onto a reserved spare pool of boxes? So this all can be done in software. A very, very simple GUI. Really, really simplifies how data centers are managed and administered to. So thank you for your time. If you have any questions for me, by all means, give me a shout at kostreich@egenera.com. Thanks again for your time.